The following pairs of compounds, we are trying to identify them as constitutional isomers, diastereomers, and enantiomers, same compound, or just completely different compounds. So the only place where different compounds would apply is if we have different chemical formulas. In part A, you can see the arrangement of both the bromine and the chlorine has been reversed from the structure on the left to the one on the right. However, there's no chiral center in this molecule. At that carbon, the other two groups are both ethyl groups. That means these have no stereocenters, and therefore they are the same compound. In part B, one of our stereocenters has remained the same, but our second stereocenter has been reversed. So overall in this molecule, we have two chiral centers. One has stayed the same, one has been inverted, and that makes these diastereomers. In part C, the challenging part in part C is that there's no chiral center in this molecule. There's no tetrahedral carbons. All of our carbons are either sp2 hybridized or sp. But hopefully you recall we did say there are cases where we can have a chiral molecule without any chiral centers. And the functional group that we find here in part C, which is known as an alene, the two consecutive carbon-carbon double bonds, can be chiral. Now on one end of the alene, we have fluorine and bromine, and they're in the same configuration. But on the other side, the iodine and the chlorine have been reversed. And so while it may not be apparent, alenes are chiral molecules when they have four different substituents. And so since one side has been reversed and one side has not, that makes these enantiomers. If you're having trouble seeing that from the two-dimensional structures shown here, this would be an excellent case where building a model using your model kit of each of the two compounds and attempting to superimpose them would show you that these two molecules are non-superimposable mirror images. Part D looks pretty straightforward because there's clearly no chiral centers. We have 2, 4, 6, 8, 10 carbons on the left and 12 carbons on the right. So, given the chemical formulas are not the same, these are just completely different molecules. And finally, in part E, we have just the one chiral center. It's been inverted, and that makes them enantiomers.